When this behemoth takes to the air, the enemy has no more arguments. The rumble of the huge engines lets everyone know from many miles away that this is not going to be a good day for anyone. Its steel body glistens in the sun, and its 180-foot wingspan can block its light from enemies on the ground. At one point, a compartment containing 30 tons of explosives is opened and everything stops, except for 20 missiles and 80 440-pound bombs that instantly hit the target, giving no chance of escape. It was designed at a time when reliability was valued, and the B-52 is still a reliable mainstay of the U.S. Air Force. July 2024 was marked by one of the largest air exercises as part of the Bomber Task Force 24 mission. Two B-52 Stratofortresses participated in joint exercises with the Romanian and Finnish Air Forces. This mission was intended to improve combat tactics and demonstrate the ability of the United States to rapidly deploy forces in Europe. These flying fortresses did an excellent job with their mission. It's difficult to overestimate the historical significance of the B-52. Even 70 years after its first flight, these aircraft remain indispensable. And the next modernization will allow them to carry out missions until 2060. That's 100 years in the air. Takes a lot of effort to make this aviation legend fly and do its job. Before the flight, the B-52 crew participates in a detailed briefing to determine the flight route, targets, potential threats, and contingency options in case of unforeseen situations. It considers weather conditions, enemy air defense capabilities, and coordination with other forces involved. Then the team of mechanics and engineers proceeds with the routine check. All mechanical elements, control surfaces, flaps, ailerons, and stabilizers are checked. After that, the updated avionics, which includes new radar systems and other modern technologies, are tested. When the test is successful, they move on to the old-fashioned engines. They're launched and tested on the ground, checking thrust, fuel consumption, exhaust gas composition and temperature, and other indicators. Mechanics also inspect the engines for damage or signs of wear and tear and check the condition of compressors and turbines. If everything goes well, only then is it time to refuel. The B-52 is refueled in accordance with the needs of the mission. Not only the flight distance is taken into account, but also the possibility of refueling in the air. It consumes 3 tons of fuel per 62 miles. But the most interesting stage is the loading of the ammunition. Engineers check the settings of the guidance and launch systems, and it takes a lot of time because the Stratofortress can hold 32 tons of various weapons. So all the systems are ready. The engines are running and driving the airplane down the runway. The experienced crew feels no more strain than another aircraft when taking off from the ground, which is due to the excellent engineering solutions used in the development of the bomber. After some time in the air, the crucial moment comes. It's time to get rid of the payload and destroy the target. Before the bombs are dropped, the aircraft enters a stable horizontal flight. This allows the crew to align the aircraft on a precise trajectory for targeting. The aircraft is equipped with modern radars and infrared sensors that ensure accurate target location, even in poor visibility conditions or during night missions. In addition, the B-52Hs participating in the exercise are equipped with GPS-guided JDAM missiles, which guarantee high accuracy of the strike. At the right time, the weapon operator or an automated system starts the bomb drop procedure. The bomb bay door opens and the control system calculates the time and coordinates of the drop to achieve maximum accuracy. The headquarters is watching the bombing process with intensity, recording all the pros and cons of the team and equipment. And now guided and unguided munitions are coming off the board. A huge destructive force, capable of leveling entire neighborhoods, is directed at models specially built for these exercises. A moment, and puffs of smoke rise into the sky with deafening explosions. The target is hit. The crew is ready to turn the bomber back to the airfield. This mission was perfectly executed, but in the pre-digital era, there were also unfortunate incidents. During Operation Linebacker 2 in December 1972, B-52 crews encountered problems with the mechanical bomb drop systems. The bombs could get stuck in the bomb bay, requiring the crew to make sharp maneuvers to drop them. This sometimes led to accidental bomb drops outside the target area or created delays in dropping, which reduced the effectiveness of the strike. Such problems forced engineers to improve the discharge systems. Today we can see the results of their work. The clear coordination of all systems and mechanisms has made it impossible to make a mistake. After the mission is completed, the crew transmits all the data collected during the flight for further analysis. This includes conversation recordings, data from aircraft instruments, video footage, and information from external systems such as radar stations. The flight is analyzed, during which the crew actively discusses what can be improved during the next flights. In general, the results of the exercise once again confirmed the change in the tactical landscape of modern warfare. B-52 bombers must now not only perform strategic missions, but also operate effectively in difficult tactical conditions where the enemy uses modern methods of counteraction. This requires constant updating of tactical techniques and improvement of operational thinking. The exercise tested the use of active electronic warfare systems by a simulated enemy. This is seen in the Russian-Ukrainian war, and NATO is actively adopting this experience. The results of this exercise are used to adjust tactical techniques and improve methods of evading enemy electronic warfare and air defense. In addition, joint exercises with allies have demonstrated to potential adversaries the coordination of international efforts. Interaction between different air forces and units on the ground requires well-established protocols and a common understanding of combat missions. This is especially important in the current threat environment for NATO's eastern flank. Despite its advanced age, the B-52 bomber still has no replacement. Due to the relative cheapness of maintenance and use, this work of military art will serve the U.S. Army Air Force for many years to come. But have you ever wondered how an American bomber manages to drop 3,000 bombs in just 3 minutes? To do this, it was necessary to involve the best engineers from around the world, who over many years of testing managed to create a completely new weapon, which combined with invisibility will become the most powerful tool of influence in any conflict. The Northrop B-2 Spirit is an American strategic bomber that has impressed the world with its capabilities.
Basically designed so that it minimizes the amount of radar that can be returned to the original source by, unlike the 117, which uses faceting.
This was the first production airplane to be designed as a flying wing, which completely changed the idea of aviation. Could people have ever thought that one day they would see a 160 by 65-foot steel boomerang in the sky, capable of destroying a city with a single projectile? The main ability of the B-2 is also hidden here: invisibility. How much harder do you think it is to detect the Spirit than a regular airplane? 10 times? Maybe 100 times? That's wrong. 1,200 times. This means that enemy radar needs 1,200 times more power to recognize it. As we both understand, this is extremely difficult.
It's designed to basically kick down the door to open up that entryway.
You've figured out the stealth, but you're probably wondering why we need it at all. You can just fire a missile at the enemy and that's it. But the B-2 Spirit is much more destructive than any missile, as it's capable of producing a hail of several thousand explosions. No other aircraft can do this. This technology has been secretly developed for more than 10 years and it's finally been tested. But be ready, because the purpose for which it was done will definitely surprise you, or maybe even scare you. The preparation and planning of such an important mission is very thorough. From intelligence gathering to target selection, every detail is carefully considered. The logistics of coordinating such an operation are staggering, as success requires several teams to work in perfect harmony. Bombers and their crews receive special training. The crews train on high-tech simulators that reproduce flight conditions. It's almost the same as if you decided to play a war game on a computer, but there's more responsibility.
It will operate in tomorrow's high-end threat environment, and it will enable America to outmaneuver, to outpace, and to outmatch our adversaries. It will deter aggression.
In the case of the B-2, flights take place at night and in good weather. The crews are also studying strategies and tactics for using bombers in various combat scenarios, including breaking through air defenses and striking key enemy positions. For this purpose, buildings are constructed on training grounds only to be blown up from aircraft. That's how people work. The crews of bombers capable of carrying nuclear weapons undergo special training in the management and use of the nuclear arsenal, including safety procedures and launch protocols. Of course, the nuclear bombs are usually replaced by dummies in training, But the pilot is still obliged to know the radius of destruction and other aspects that may be critical. And when the pilot is fully trained, the aircraft is put on alert and the range is built. It's time to start the full-fledged explosions. All safety procedures must be taken to ensure that such a combat operation is successful and the pilot remains safe.
B-2 enables us to pull the wool over the enemy's eyes and significantly darken his view. So with that in mind, there may be advantages to making different turns and going different directions en route to the target with the bomber to enable us to accomplish the mission.
It's necessary to equip the aircraft with the necessary ammunition before the battle. For this purpose, the bombs are transported on pallets by a special transporter. I can't even imagine how scared the driver must be, because he's carrying something that can blow up the whole city because of the slightest mistake. Then the military needs to provide reliable reconnaissance and protection for the bomber. It's necessary to accurately determine the location of the enemy so that the entire nuclear power does not fall somewhere else. The newest reconnaissance drones, the Global Hawk, are used for this purpose, capable of monitoring more than 130,200 square feet of territory from an altitude of 72,200 feet. Modern F-22 and F-35 fighters, as well as air defense systems, are responsible for covering B-2, and videos about them are also posted on the channel. In the case of the Spirit, its escort lasts exactly until it reaches the boundary line, a line after which enemy radars can easily detect other aircraft. Then the Spirit's left alone and the mission comes to its peak.
It's a stealth aircraft. It's designed to basically kick down the door to open up that entryway.
The pilot needs to gain sufficient altitude to reduce visibility as much as possible. The B-2 copes with this with flying colors, as it's capable of reaching an altitude of 69,000 feet. At this altitude, it's almost impossible to capture, and given all the work done to make it invisible, we can say that it really becomes a ghost, bringing destruction. As soon as the pilot's over the target, one button and launch. Mission accomplished. Pilot returned to base.
Like I said, we knock the door down, we go in first, and lead the way for other aircraft with a larger radar signature to come in and strike targets to drop those unguided weapons.
Such a powerful nuclear bombing has catastrophic consequences, affecting both the explosion zone itself and remote regions. The blast wave from thousands of shells instantly destroys buildings and infrastructure along with enemy military equipment. As you already understand, nuclear bombing is an extreme threat, the consequences of which could be catastrophic. And this is what every state fears. That's why strategic bombers with their arsenal are created primarily to deter the aggression of potential enemies. The impact on the target is significant, but we cannot ignore the collateral damage that could have occurred. It's a reminder of the cost of war, even in the age of advanced weaponry. Nevertheless, the United States wanted to go even further and tested a new projectile, the B-5113, which will replace the old models. The B-5113 has the same power as the nuclear B-61-7, which was developed in the 1960s.
The 6112 program started in 2010. We really started the aircraft compatibility testing in 2013.
The new bomb will have a capacity of 360 kilotons, while the last nuclear bomb produced by the United States had a capacity of only 50 kilotons. The power of the new product is equivalent to the explosion of more than 2,000 non-nuclear missiles. But the Spirit is capable of carrying something even more terrifying. It's a cluster version of this projectile, and each of its hundreds of parts contains a miniature nuclear warhead. Given the number of bombs that can fit in the hull of a bomber, one such salvo will create about 3,000 explosions over an area of tens of miles. But all these experiments of new bombs were just a test for the future adaptation of this technology to the B-21 Raider bomber, so that it could drop the same number of projectiles, but in unmanned mode. Reflecting on the spectacle we've witnessed, it's important to remember the consequences of such a show of force. The B-2 bomber, which dropped 3,000 bombs in just 3 minutes, is a serious reminder of the destructive potential of modern military technology. It's worth considering whether it was really worth creating such a weapon. Could it be that the way to peace is to give up nuclear weapons? However, by giving up nuclear weapons, we face another difficult challenge: how to ensure security and stability in a world where every move can lead to a new war. A world without nuclear weapons may seem like a utopia, but the realities of international politics and history shows that the balance of power plays a key role in preventing major conflicts. At the same time, the moral aspect of this issue cannot be ignored. Technological progress should serve people, not jeopardize their existence. Instead of increasing the arsenal, perhaps we should focus our efforts on developing diplomacy, international cooperation, and mutual understanding between nations. Ultimately, the choice is up to us. We can continue the arms race, risking the future of our planet, or we can work together to find ways to coexist in peace. The responsibility for the future lies with each of us. We can achieve true and lasting peace only through conscious and responsible decision-making. Please think about it. If you were impressed by the power of the B-2 bomber in action, don't forget to show your support by liking and sharing this video. By doing so, you'll help spread the word about the impact of modern military technology. And to learn more about military operations and technology, don't forget to watch our other videos. Thank you for watching.